Hey everyone, welcome back to our Terraform tutorial series. Today we are diving into Terraform state file. By the end of this video, you'll know what Terraform state file is, why it is important, and how do you manage it effectively. Here are the things that we're going to look into it today. First, we will start with an introduction to state file, and then we'll discuss why state file is important. We'll explore then how state file works, followed by the breakdown of the components of the state file. Then we'll cover how do you manage your state file, including some of the key commands to remove or move your resources. And then we'll talk about the benefits of storing your file remotely. We're also going to look into it how you could enable locking for your state file when they're stored remotely to avoid any conflicts. We'll also discuss some of the security aspects of state file and how you manage your state file so that it stays secure. Finally, we'll wrap up with a hands-on demo where we will put everything into practice that we're going to discuss in the first half of the video. Feel free to skip any sections that interest you using the timestamp. By the end of this video, you'll have a solid understanding of what state files are. So let's get started. All right, let's start with the basics. What is a Terraform state file? Imagine you're playing a video game and you save your progress. The save file is gonna keep track of where you are in the game, what items you have, what quests you have completed. The Terraform state file works the same way. It keeps track of your infrastructure's current state, like what sort of a servers, network, or database you have created and what state they're in. The state file also maps your configuration files, which are like the blueprints, to the actual resources in the real world. In our case, it could be AWS, Azure, or even on-prem resources. It also keep a good record of the resources that you have created by defining the resource IDs and their dependencies, which help Terraform understand what exists and what need to change. So just like saving a file in the game, the state file is essential for keeping everything in sync. Why is the state file so important? Think of the state file as an instruction manual for Terraform. It helps Terraform plan and apply changes to your infrastructure. When you make a change in your configuration file, Terraform uses the state file to figure out what has changed and what needs to be updated or created or even destroyed. The state file also provides a consistent view of your infrastructure for teams that are working together. Everyone on the team can see the same information about what resources exist and how they are configured. And additionally, the state file is crucial for recovering from mistakes. If something goes wrong or you need to roll back changes, Terraform state file can be used to revert to its previous state and fix any issues. Now let's look at how the state file works. The state file is stored in a JSON format. JSON is a simple text-based format that is easy to read and understand. This format kind of allows Terraform to store detailed information in a structured way. Terraform automatically updates the state file whenever you make the changes, so you don't need to manually edit this file. Terraform handles this for you. By default, the state file is stored locally in your working directory, but you could also store it remotely. The remote storage is useful when you're working with teams, and it also provides a better security. We'll cover remote storage options in a bit. Let's break down the components of a state file. First, you have version. This indicates the state schema version. A Terraform core uses this to read and write the state file correctly. Then you have Terraform version. This shows the version of the Terraform that you used when you created the state file. Then you have a serial. This number increment with each Terraform apply. Then you have lineage. It's a unique identifier for the state file within a given backend. It changes only if the state file is moved from one backend to another one. Then you have outputs. These are the outputs provided by Terraform code that created the state file. Then you have resources. All the resources that are being created by your configuration files would be listed here. At the last, you have check results. This would be a status of the conditions that Terraform checked, like a precondition, postcondition, or any sort of a variable validation. All those checks would be listed here. Managing state files kind of involves using a few key Terraform commands. Let's go through some of them. First, you have Terraform state list. This will list all the resources that are in your state file. And then you have Terraform state show a resource. This will show a detailed information about a specific resource. Then you have Terraform state move. This essentially moves a resource to a different location. Terraform state remove would help you remove a resource from your state file. For the best practices, always keep regular backup of your state file. This way, if something goes wrong, you can restore it from the backup. Also consider using remote storage for your state file to improve security and support team collaboration. Storing your state file remotely has several benefits, especially when you're working on different teams or working on larger projects. Think of it's like using a cloud service to store your important documents instead of kind of keeping them only on your laptop. By storing your state file remotely, you can work together with your team more effectively. You also kind of keep your state file secure. Popular options for storing your state file remotely include AWS S3, Microsoft Azure Blob Storage, and Terraform Cloud. Here's a quick sample of how to set up your remote storage with AWS S3. This configuration tells Terraform to store the state file in a S3 bucket, which kind of making it easier to be accessed and secure for everyone on your team. When we'll do the demo later in the video, we will demonstrate how you could store your state file in a S3 bucket and how you could even enable the locking. Handling state logs is very important to kind of avoid any errors from multiple changes that are happening at the same time. You may have a lot of scenarios when multiple people in your team would trying to update your state file at the same time. Think of a state log as a do not disturb sign. When Terraform is making changes, it puts the sign to kind of prevent other from making changes. It's kind of essentially send a message to other team members saying that your particular team member is making the changes, so you should wait until those changes are done. Each backend uses different methods for locking. For example, when you're using AWS S3, it uses DynamoDB for this, while Terraform Cloud has its own built-in logging system. This logs essentially kind of ensures that the changes are applied in the correct order and you don't have any conflicts in your configuration. Whenever you're working with state file, you always want to make sure that you have it secure because it contains sensitive information. One way to protect is by using encryption, which kind of ensures that even if someone gains access to the file, they cannot read its content. Then you could also have an access control, which would help you to kind of manage who can view or modify your state file. You could set the permissions to ensure that only authorized users can make changes. You also want to follow the best practices like regularly auditing and monitoring to kind of keep track of who is accessing the state file to ensure that it kind of remains secure. Alright, for this demo, I have a single file called main.tf and I'll be using the terminal on right to run any Terraform commands. If we go through the content of the file, the first we have Terraform block, which is specifying the provider that I'm using. Then there's a provider block adding additional properties to my provider. Then I have 3 resources listed that I want to create, and the first one is VPCs, where the CIDR block is specified, and then you have EC2 instance and a security group. Now let's initialize our Terraform configuration by running command terraform init. Once the initialization is finished, you would notice that you have a new folder sitting in your working directory .terraform, which is kind of the place where the plugin is stored for your AWS provider. Once the configuration is initialized, we could create our resources by running Terraform apply command. You notice that as soon as the Terraform apply command runs, Terraform's gonna give you the list of the resources that it's gonna create. Some of the properties are known, like some of the things that we have defined in configuration file, but a lot of things are not known, which is very normal. And all of these properties would be known once the resources are created. To create the resources, we have to confirm by providing yes and hit enter, and then Terraform would create the resources for us. This would take about like 30 to 40 seconds to create this many resources. So I'm gonna pause this for a bit. All right, so the Terraform apply command is completed and it has created 3 resources as we specified. And as soon as the Terraform apply completes, you would notice that the Terraform state file would have get created as well. And it would contain all the information about your resources. So let's quickly review Terraform state file. And the first, you have a version, and then you have a Terraform version specifying what Terraform version we are using. And then there's a serial is a number of changes that Terraform making plus Terraform apply. The changes that our command last time made, it created 3 changes, which essentially created 3 resources, and we run Terraform apply, thus this number is 4. And then you have a lineage. It's a unique identifier for the state file, and this is something that would change, as we talked about in the slides, that if we move it to a S3 bucket or any other remote location. And then you have outputs, essentially anything that would output it from your configuration. In our configuration, there was nothing defined which would kind of output any value, so this is blank. And then you have resources. The resources is a detailed information about the resources that Terraform has created for you. You would notice that there are properties that we didn't even define, but they are listed here. So Terraform state file would have detailed information about your resources and everything that kind of depend on them as well. And pretty much any resource you create, they have a detailed information about it. In this case, it's EC2 instance, and similarly, the VPC would have all the detailed information about as well in the resource file. And at the end, you have check results. If I would have defined any pre or post condition for my resources, the results of those outputs or for those conditions would be listed here. And in my case, there was nothing sort of something like that in my configuration. So this value is null. Okay, so now let's move our state file to somewhere remote location, and in our case today, I'm moving it to S3 bucket. For this demonstration, I did have a S3 bucket created. It's called DevOps Avenue, and then there is a directory called Terraform, and this is where we will be storing our state file. And so let's configure that in our configuration so that the Terraform state file moves to S3 bucket. So to do that, you would define a backend block within the Terraform block. So do that, just type backend, and then you select the location or the remote source where you want to store your state file. In my case, it's going to be S3, so I select that. And for this, it requires certain arguments. It expects you to provide a bucket name, and for that we could just say bucket, and I could add the value DevOps Avenue, and because that's the name of my bucket as we just looked at it here, DevOps Avenue, and then you have a Terraform directory within it, and you specify the bucket name here, and then you specify the key, and you're just telling what you want to name your state file and where you want to store it further down in the S3 bucket. And in our case, it's gonna be Terraform. It's a directory, and I want to name my state file that state.tf state. Specify that, and you have to specify the region where your bucket is. And in our case, my bucket is in US East 1. I could verify it by going to its properties, and I have to specify its value, US East 1. As soon as I add values for or specify the configuration for remote storage for my state file, if I try to run Terraform plan now, it would tell me to, hey, reinitialize your configuration because you have updated your backend configuration where you want to store your S3 file. So we'd have to run Terraform init again. And as soon as you run Terraform init, you would get a message from Terraform saying that, hey, do you want to copy your existing state to a new backend? You have to confirm and just type yes. And it would transfer your state file from locally to S3 bucket. As soon as the transfer happened, you would notice that the state file that was sitting in your local directory is empty now. Terraform does take a backup before it moves to a new backend, but the state file that Terraform would refer to is no longer has any content in it. It would refer to it, the state file that is sitting in your S3 bucket now. So if I go to my bucket, you would notice that under Terraform directory, I should have a state file sitting here now. So now my configuration would refer to the state file that is stored remotely. Now let's explore locking your state file, and first we look at it, why do we need to lock it, and then we will go through the process of locking your state file. First, for this demonstration, I do have a Cloud session running, which would kind of essentially simulate as another user for us who would essentially try to make changes to our state file or to our infrastructure. What I will do, I'll copy my configuration and put it in this session. So I'll just create a new file, main.tf, and paste my configuration here. So once my configuration is listed here, I have to run Terraform init. Since it's running from a new session, I would have to specify the migrate state option while I'm running Terraform init. So I'll do that. This would initialize my configuration on this Cloud session. What we will do here, that I'll make some sort of a change to my configuration. We'll update some sort of a tag for my EC2 instance. I'll change the value from 55 to 66 and save my configuration, and I will try to run Terraform apply. And as you would expect, that the Terraform is updating the tag value from 55 to 66. Now we're gonna do the same thing in our local environment from my terminal. So what I will do in this configuration, I'll update the tag value to 77 or whatever, and I would run Terraform apply. And as you would expect, the Terraform is updating the value from 55 to 77. But if you would have noticed that I'm able to run Terraform apply at the same time as this user who's running it from Cloud Shell. You do not want that to happen in your environment. You don't want to have multiple people making changes to your infrastructure. You may want to have a scenario where this user makes the changes and changes the value to 66, and then I, in a local terminal or the local user, would be able to see that when I run the Terraform apply, and then I would update my value accordingly. So that's where you would need to have some sort of a locking in place so that multiple people can make the changes at the same time. So let's enter no in for this one and cancel the apply, and do the same for Cloud session as well. To enable locking, you need to have a DynamoDB table created, and that's what we're gonna do. Gonna go to AWS console and create a DynamoDB table. When we're creating the table, you could name the table as you like, but when it comes to defining a partition key, it has to be named lock ID, and L capital and ID should be in uppercase as well. If you just use lowercase for lock or lowercase ID, the locking would not work. So you could, after defining partition key, you could leave all the options as default and click create table. This process shouldn't take too long. It would be finished in 30 seconds. So now what we need to do, we need to update our configuration and add this DynamoDB table name. So what I'll do, I'll come to my configuration here, and in the same block where we specify the S3 bucket, I will add the DynamoDB table. So I have to enter DynamoDB table, and for the value I would provide the DynamoDB table's name and click save. And I'll do the same on my Cloud Shell environment, so that the configurations do kind of match. After specifying the value, I'm gonna save my file, and now I will run the Terraform apply again. But before I run it, I would have to run Terraform init again with the migrate state option, and this would kind of reinitialize my state file configuration, and which would also include Terraform would now know that there's a DynamoDB table in place for locking mechanism. I'd have to do the same on my local terminal. I have to run Terraform init. Okay, so this has initialized my configuration again. So if I would run Terraform apply, I'll do it on Cloud Shell session here. So I'll run Terraform apply. As expected, like, now Terraform updating the value from 55 to 66 for my tag. And if I run Terraform apply on my local terminal now, I would get an error message saying that my file is locked to a user and it would even tell me what the user is, and provide some sort of state file path that it's using. So now my local user not able to make any changes. I would only be able to make the changes if this user finish its apply or cancel its, like, Terraform apply. So what I will do, I will finish this one on my Cloud Shell environment, and this would update the tag value to 66. As you would see in a previous run when we did it, it was changing the value from 55 to 77. But since the state file has been updated, if you run to Terraform apply now, it would change the value from 66 to 77. And that's something we're going to see when you Terraform apply would display what's going to change. So yeah, as you could see, in the state file, the value is 66, and that's something the Cloud Shell user did, and now it's updating the value to value 77. I could confirm this one, or I'll just hit no here. So that's why the locking is very important, and it's a great practice so that you don't have any unexpected issues when multiple people make the changes at the same time. Now let's explore some of the commands related to Terraform state file. If you want to manipulate any of the resources that are sitting in your state file, you could use Terraform state command and then the options that are available with it. The first one is the list one. If you run Terraform state list, it would tell you the resources that are being managed by Terraform. If you want to see more information about your resources, you would run Terraform state show and specify the resource that you want to know more about it and all of its properties. In this case, I'm showing the more for VPC here, and this is going to give me all the details about that are in the state file. Now I would try to remove a resource from state file, Terraform state remove, and specify the resource that I want to remove. So I'll remove say just a security group. Now the resource has been removed from a state file. This isn't something that you want to do in a production environment. So if I run Terraform apply now, Terraform thinks that the resource is no longer being managed by Terraform, so it would try to recreate it. And this is one of the reasons that you shouldn't manipulate or update your state file just like this. If you are removing something from your state file like the way we just did, just make sure that you update your configuration files accordingly. If I had removed a what did we remove? We removed a security group. I should remove from my configuration file as well. So if I, after removing from my configuration file, and if I run Terraform plan now, I shouldn't see any changes. So you should not just delete the resources from your state file. You should also remove it from your configuration files. I did make a video as well covering on how you could safely remove the resources. Do check it out if you're interested. And that's it with this video. We covered importance of state file, its component, and how you configure state file. We also looked into how you can implement the state log and some of this useful commands. I hope you found this demo useful. If you did, please give it a thumbs up and subscribe to my channel for more content like this. Thanks again. Have a lovely day.